Hey guys, Travis here again. We're doing part two of four. And if you haven't checked out the part one video, go check out the part one video. But you don't necessarily need it to do part two. All you got to know is that we will be utilizing these two formulas again. And they're just basic formulas that we use to find out the amount of money that you have saved or earned via interest. So, yeah. Once again, the R stands for your interest rate. Interest rate. The N stands for how often it's compounded. How often compounded in reference to a year. So that's why the T is number of years. I guess you kids call that hashtag, right? But back in the day, they used to call that number of years. And let's see, R, N, T, and yeah. That's pretty much it. The P stands for principal. Sometimes they'll call this also the initial amount. The initial amount. Depending on what textbook you use, sometimes they use A naught. And it really is just an exponential expression, guys. That one is like 100%. So that R over N is really like your interest, right? Quote unquote. So yeah, guys. So depending on what textbook, some textbooks will say that I equals R over N, or they might not even mention that. They might even push the N outwards, and they might have it as 1 over N as an exponent. So it just depends what textbook you use. But I think most will use this. Delta goes through this route as well. So I think you guys will find it pretty easy. A quick chat. We're going to be using logarithmic properties. I like natural log over log. I guess log with a base. You can use log with some base of x, but this is the same. By the way, there's something called the change of base formula. This is the same thing as ln of x over ln of b. You won't necessarily be utilizing that, but it's something to know. Really, the log properties are the same as your exponential properties. Sorry, guys, I had some coffee and maybe the coffee wasn't good for me. But yeah, pretty much they're pretty much the same, guys. Log, or you know what? I'm gonna use ln. Ln of AB is the same thing as ln of A plus ln of B. And then ln of A over B is the same thing as ln of A minus ln of B. And then the one that we will be utilizing the most is the power rule of logs. So it's like ln of A to the power B equals B ln of A. So that's the one we're going to be using. This is called the product rule of logs, the quotient rule of logs. And in case you're wondering, they're related to exponentials. That's because logs and exponentials are inverses of each other, right? When you multiply, in case you're wondering, Chop, I have no idea what you're talking about. When you multiply x to the power n times x to the power n, remember what they tell you to do when you have the same base? You're going to add them, x to the m plus n. So that's what they're doing. That's what they're doing. See that plus symbol? When you have something like x to the power m over x to the power n, and you have the same base, x and x, you're going to subtract them, x to the m minus n. And don't be a robot. Make sure you understand why. Really quick, x to the third times x squared. So that means that you have 3 x's, x times x times x. And then this means that you got 2 x's times x. Well, look how many x's you count. There's 5 of them. And this is a product, not a sum. So x to the power fifth. Notice what you did. You just added. And if you have the same thing, x to the power 3 over x to the power 2, well, x to the power 3 means x times x times x. X to the power 2 means x times x. Bam, bam. Oh, look, there's just one x. So it's the same thing as 3 minus 2. So yeah, that's how. See, they're pretty much similar. So yeah, if you have no idea what I'm talking about, guys, let's say like you haven't even touched algebra 1 yet, and you've never heard of exponential or log properties, this might be a little tough for you. But if you've had a little bit of background of logarithms, because these are not notes, right? This is kind of like an overview. So if you've never seen a log or never even spoken about logarithmic functions or exponentials and what's inverse of exponentials and all that good stuff, you might have a hard time with what we're talking about right here, just the beginning in here. You might be like, what are you talking about? So come see me. Or, if you're some of my fans, which if you're watching this, thank you. Send me, put it in the comments, and I'll try my best to answer your questions. All right, guys. Let's go ahead and start. Let's just go right into it. You're going to need a calculator. It says Delgadillo invested $4,900, so this is your principal amount, in an account paying an interest rate of 3%, so that's your R, compounded monthly, so N equals 12. assuming no deposits or withdrawals are made. Yeah, because we're keeping it an introductory lesson, right? How long would it take to the nearest tenth of a year for the value of the account to reach 5,920? Okay, so let's set it up. So this is going to be using A equals principal parenthesis 1 plus R over N to the raised to the power NT. That's the one we're going to use. And this 5,920, that's the final amount that we want. Final amount. So here we go. I'm going to put that 5,920 equals, and the principal amount is 4,900, comma, 1 plus the rate is 3%, 0.03. Move the decimal 2 times to the left to get your decimal to, so 3% is equivalent to 0.03. And it's compounded 12 times, or within the year. And raised to the power NT, so let's see, 12 times, what was my time? Oh, that's what they're looking for. Okay, so I'm going to write 12t. 12t to the nearest tenth of a year for, okay. So what you're trying to do, guys, is you're trying to solve for 12t. So your first action, you have a product here. You have 4,900 times this stuff. I guess if you want, you can turn that into a number. I'm going to leave it like that for now. And the first move, my first move is I'm going to divide by 4,900. So divide by 4,900, divide by 4,900. And what you're going to get, let's see, you're going to take your calculator. 5920. Don't approximate anything. Use the exact rules. 5920 divided by 4,900. So I'm going to go, and I already forgot. 5920, 4,900. Okay. 5920 divided by 4,900. Hopefully it's a nice, pretty number. Bam. Okay, it's not. We're going to use those digits. What do you want to store? Let's just go down the alphabet, right? I'm going to store it to A. So every time you see me write A, I'm typing it in this number. It keeps going forever, guys. I guess you don't have to. You can just leave it as that fraction, 5920 over 4,900. But there it is. All right, so there it is. And now I have this here by itself. If you want to convert this into a number, you can, but I'm going to leave it like that for now. You know what? I'll leave it like this for now too. 5,920. And I'll show you that maybe doing that whole, calling this A. So maybe I shouldn't have called it A because of the A there. But you'll see right now what I'm talking about. 1 plus 0.03 over 12 raised to the 12t. All right, so now what I want to do, I want to bring this 12t down. So the only way you can bring that 12t down, well, that's not the only way, but there's other. The best way that we know how to do right now is to use our power rule for logs. So I'm going to go, I know some of you are saying like multiply this by 1 over 12, and then multiply this by 1 over 12, or raise to the power 1 over 12, raise to the power 1 over 12. But that's another way. I don't want to talk about that route. And then eventually you're still going to be doing the natural log anyways. Natural log. When you do that, see, so it's natural log of all this. I can utilize, see that 12t, that's kind of like that b here. I can bring that, see how it brings that b to the front? And there it is. So this is like my b, and I'm going to bring that, bam, right there. So here we go. I'm going to write ln of 5920 over 4,900 equals 12t ln of 1 plus 0.03 over 12. So now what we want to do is we want to get that t by itself, right? So all you're going to do is divide by everything except the 12. Now, the 1 plus 0.03 over 12, this is the argument of logarithms, guys. So that stays together. If you wanted to make that a number, that's fine. When I mean a single number, I mean like add this in the calculator and put that expression in there. But I'm not going to do that. I don't know that the answer is this. We'll see if we get that right now. So I'm going to divide by 12 ln of 1 plus 0.0312. So whenever you divide that, those cancel out, see, with those. And whatever you do to one side, you do to the other. So I'm dividing by 12 ln of 1 plus 0.03 over 12. So here's how it looks. You're confusing me. All right, I hope I'm not, but if I am, let me know. T equals, so what I have on the top, ln of 5920 over 4,900, and I'm dividing by 12 ln of 1 plus 0.03 over 12. See, so this is why sometimes I want to create like a number for this, and so it doesn't look as not that it's ugly, but let's see. I'm gonna take my calculator, guys, and I'm gonna just type that in. So I'm gonna take my calculator here, and I'm gonna go. I'm gonna make the fraction feature first, and here we go. I'm gonna type in ln of that. So ln. And then I'm going to use the fraction feature again. And I'm going to put 5920 in the numerator. 5920. And I believe it was 4900. There it is. And I'm dividing by 12 ln of that. So let me type that in. 12 ln. And I'm just going to type that in. Let's see. Well, it's first 1 plus, right? 1 plus. And then my interest rate was 0.03, 3%, and dividing by 12. So there it is. I typed it. It looks exactly like that. And let's push enter. And I get 6.311. And there it is, 6.3. The one to the nearest tenth. Yeah, nearest tenth. So 6.3 years. By the way, guys, just for, well, not necessarily for kicks, but I just want you guys to know that 0.3 means 30% of a year. So let's see, 3, 6, 9, 12. So that would be March, right? So if you take your 12 months and you were to go 12 times 0.3, so that tells you that it's going to be, so the third month, so it would be in March, and that 0.6 is 60% of 30 days, right? So 0.6 times 30 or 31, depending on how many days are in March. So it will take you until 3 years and then another 3 months and 18 days for you to reach 5,920. So there it is. Remember when I told you guys that I made that A? Did I make this A? I don't know if I should bring that up or not. But yeah, you could have also done, let's see, alpha y equals, and see if you think it's easier. ln of alpha a, and then on the bottom here, just leave it as 12 ln 1 plus alpha fraction. And I guess you can use as many variables as you want. 0.03 over 12. And we should get the same answer, guys. Bam. Yeah, we got the same answer, digit per digit. So hopefully that made sense. I know maybe it looks kind of like, what are you talking about? So if you feel like I went too fast, I'll try to slow down. But rewind this, guys. Rewind. Just push the back button, I guess, if you guys want to. Let's see. Vasquez invested $2,500 in an account, paying an interest rate of 2.7%, compounded daily. All right. So if it's compounded daily, that means n equals 365. And this is how much he invested initially. So that's your P. And this is your R. Assuming no deposits or withdrawals are made, how long will it take to the nearest year for the value of the account to reach? So I want to reach that much. So 3,460 equals 2,500, parenthesis, 1 plus 0. Let's see, 0.027. 2.7 over 365. So it's important to know that it's just this, so it's 1 plus 0.027 over 365. This is a little fraction here, and is raised to the 365t. All right, so first move, divide. And sorry, guys, I know that my handwriting is really sloppy here. So divide, this is a product, 2,500 times this, times 1 plus 0.027 over 365. If you think it's easier to just create a number there, that's fine. So divide. So here's what I have. 3,460 over 2,500 equals 1 plus 0.027 over 365, parentheses, to the 365t. You're trying to solve for t. It says to the nearest year, guys. So you're solving for t. So solving for t. All right, the next move. I want to find, or I need a way to bring this down because I'm trying to solve for t. And so we're going to use our log rules. So I'm going to put use log rules. So if I write ln on one side, it's ln of all this, right? I have to write ln on the other. And this is your argument. What I mean by argument, that's like your, f of x, that's an argument. So this is the argument that goes inside of natural log of your ln. That's the argument of ln. So here we go. I'm going to move this to the front. So now I have this. I have ln of 3,460 over 2,500. I hope that doesn't bother you guys that I don't put a comma. I just don't want to confuse that for a decimal. So that's my habit. I hope that you don't get annoyed by that. 365t ln of 1 plus 0.027 over 365. All right. Now, what do I want to do to get t by itself? This is a product. This is 365 times t times ln of all that. So what you want to do is you want to divide, right? So here we go. T equals, this guy's going to be my numerator. So I'm going to write ln of 3460 over 2500 over, and then what's going to be my denominator? The 365 ln of 1 plus 0.027 over 365. I feel like I warmed up, so hopefully I'm explaining this better. At least in my head, I feel like I'm explaining it better, but you let me know. Let me know. If something doesn't make sense, please swing by or put it in the comment section. All right, guys. From there, that's it. Type this into calculator. Type into calculator. Make it look exactly like that, because you guys are going to be testing on this pretty soon, right? In Decathlon. So make sure that you type it in exactly like that. You have a calculator, you have a TI-84. So here we go. I'm going to use the fraction feature, alpha y equals enter. And I'm going to type ln. And I'm going to type first, let's see, what am I going to type first? Well, I have to type this, right? 3460 over 2500. So 3460. Let me use the fraction feature again. You don't have to, but I'm doing it. 3460 over 2500. There it is. And in the bottom, I'm going to type 365 ln, and I already forgot what it was in the 1 plus that. So I'm going to go 1 plus alpha y equals enter. And it was 3%, so 0.03. I think it was 3%. Let me check. Nope, 3% was the last question. 0.027. So good thing I checked. 0.027. And then that one, I know this one down here has to be that 365. And there it is. And then I'm going to close it. And let's push enter. And there it is, guys. 12.0366. What did they want? Nearest year. So 12 years. So t equals 12 years. And there it is. And yep, we got the 12 years. Perfect. So yeah, sorry guys about that first one there that I wrote right over that answer there. But we got it right though. All right, last one here. And then we'll set you guys loose. Sandoval invested $80,000 in an account paying an interest rate of 6%. That's awesome. Compounded continuously. All right, guys. So n approaches infinity, so we're going to use our PERT formula. Assuming no deposits or withdrawals are made, how long would it take to the nearest year for the value of the account to reach 175,600? All right, so let's see. 175,600 equals, my initial amount was 80,000. 1 plus 6%, so 0.06. Nope. We're using the PERT formula because it's compounded continuously, guys. We will use A equals P e to the RT. So there's my principal, e to the R, 0.06 times time. And that's what I want to know. So 0.06t. 0.06t. All right, first move, divide both sides by 80,000. So here's what you're going to have. 175,600 divided by 80,000 equals e to the 0.06t. Now, because, all right, something that you should know, side note. And if you haven't had any chats about logarithms, you're not going to know this. ln of e is 1 because... well, I'll just tell you, because ln of e is the same thing as log of x over log of e. And the only way this will be 1 is if x equals e. So hopefully that made sense, or I guess, yeah, I think that's the best way. I mean, I guess I could have also written it in terms of base e. I could have said log base e of x equals 1. And remember that exponentials and logs are inverses of each other. So this is saying e to the 1 equals x. Well, e to the 1 is x. So there are many different ways to combat this. Log base b of a equals, and I'm going to write the letter c. So if you wanted to turn this into an exponential, b to the power c equals a. And I guess that's another property that I probably should have written up here. Let's see, do I got space? So log base b of a equals c. So this is the same thing as saying b to the power c equals a. And there it is. All right, so I wrote it up there. Sorry, guys. I hope you guys aren't mad at me. So I'm going to write ln on one side. Whatever you do to one side, you do to the other. ln, so it's ln of all this, all that mumbo jumbo. ln of that, that's your argument. And I'm going to have, so let's see, what are we going to have? ln of 175,600 over 80000 equals 0.06t ln of e. Well, we already told you that ln of e is 1. See? Right there. ln of e is 1. So you just have this. You just have, I'm going to write it again, guys. 0.06t equals ln of 175,600 over 80,000. 000. So now to get rid of the 0.06, you just divide. And I know some of you guys are saying multiply by the reciprocal. It's the same thing, guys. So t equals, and I'm going to type all this into my calculator. All right, so ready? I'm going to go alpha, enter. I'm going to go ln and 175,600. So 175,600. And I didn't put the fraction feature. That's fine. 175,600. It's fine because we only have numbers here. You just got to be careful. 80,000. 80000. All divided by 0.06. And there it is. 13.1. Did they say nearest year? To the nearest year. So t equals 13 years. All right, guys. Hopefully that wasn't too bad. I hope that all made sense for you. If it didn't, let me know, and see. Maybe you'll see part 2, extended edition. Where I go in more detail. It's not really meant to be notes. It's really just meant to be an overview, a quick, so you guys can see the connection. And yeah, guys. So just keep me in the loop if everything made sense. All right. I hope you guys are enjoying this. Talk to you guys later. Bye.